Hello everyone, and in today's video we are going to look at some intermediate coding tips, and we'll also look at using LinQ effectively in our project as well. So with that, we'll get started. Okay, so before I begin, I just want to say that what I'm about to show is what I do to help reduce code when I'm coding. Unity is it is very object orientated, and if you still apply those object orientated rules, then you can reduce your code considerably. Now, the other thing too is this is something that I don't see taught or showcased that much, so I thought I would do a quick tutorial on doing that. Alright, so the first thing what I've done is I'll quickly show you the prefab. So I've created this prefab for a game tutorial that I've been writing called, not so much called, sorry. It's basically a tutorial to do Minesweeper. Now, as you can see in the prefab, I've got all the conditions of what that tile can be. So by default, it's in the revealed state. I've got a text component. So if I turn that on, you can see the text, and the same goes for the bomb and the flag. But I'm going to I'll get to that one a little bit later. For now, I've got a very simple one, which is called the normal tile. So basically, what I'm going to do is I'm going to show you how people would normally write something, and then I'll switch it over to the other prefab to illustrate my point. So the first thing I'm going to do is I'm going to create an empty object. Sorry, I'm not going to open that up. I'm actually going to create a C# script, and I'm just going to call this game controller. And I'm going to open that up. All right, so the very first thing I'm going to, the very first thing what we'll do is we'll do a reference to the actual prefab. So we'll create a game object, and we'll just call this prefab tile, and that's going to make that private. And the reason I do serialized field, for those that are not aware, that is because I don't want this to be changed from other scripts, but I want to be able to add it from the inspector, and you'll see that when I get to it. And I'm going to do the same thing again. This time I'm going to create a private int for, not index, int. And I'm going to call this, let's call it board width. And we'll default that to 10. And we'll do another one. And this one's going to be board height. And we'll also do that. So basically we're setting up a game board that's going to hold 10 by 10 cells. So the first thing I'm going to do is I'm going to create a start script. And I'm going to go and create a method called create game board. And I'm then going to go in and generate the method create game board, so that we can create the method rather than typing it in. And I'm going to create 2 for loops, and the first one's going to be on the Y, and it's going to be the board height. And for those of you who don't know what I did there, I just double tapped on the tab key, and the variable is then highlighted, so I can then select the variable I want. So in this case, I'm going to change this to X, and then tab again, And then I'm on the length variable, and this time I'm just going to change that to board width. So then what we're going to do is we're going to then assign a variable called go to a game object, and we're going to instantiate that prefab tool. That tile, prefab tile. New vector 3 x, y, Quaternion dot identity. And what's it actually saying? Okay, however that got in there, I don't know, but I need to get rid of that. Okay, so once we have got a reference to the game object, and basically I'll just go back to Unity, and we can see that if we run that code, it's going to create a board. Actually, no, it's not, because we forgot to add the code to our object, and we need to assign that. And as you can see, we've got a board width of 10 by board width of board height of 10. And oops, I need to adjust the camera. So because of it's a 10 by 10, generally we can halve the actual screen by moving the position of the camera like that, and that should fix it, and that'll be now centered. Okay. Oh, and one more thing, make that 6. Okay, so what we've done here is what we've created is the game board of a 10 by 10 with that particular game object. Now in Minesweeper, what we can then do is we can go generate mines, and because we're going to be generating 10 mines, let me do this very quickly. We'll do the same thing up here. Serialize field, private int number of mines equals 10. And we're going to very quickly go initialize mines placed, and equals 0. And we're just going to write a very quick while loop. In this case, it's not going to be true. It's going to be mines placed less than number of mines. And we just very quick. Oh, actually, before I do that, there's just one other thing I forgot to do. Now, when I do like cell type games like this, I usually use a list. So what we're going to do is we're going to create a private list of game objects, and we're going to call this game cells, or actually no, we'll call this board cells, and initialize this what have I forgotten? Private list game objects. That should be object. Okay. So when we instantiate the object, we now need to actually add the board cells to that list. And that would be the normal way you would keep the reference of the game object. And going back to the generate mines, so we go into niche position. So what we're going to do here is we're going to get a random position out of that list. So consider this a list of 100 objects. So it'll be from 0 to 99. So what we're going to do is we're going to go random dot range 0, comma, number of no, we're not. We're going to go board cells dot count. And random range is not coming up. Why is that? Oh, it's because, okay. Don't know why, but every now and then the system gets looked up first before the Unity engine. So if you ever get that, just remove the system. All right, so basically what we're doing there is we're getting a random position anywhere in that list. So could be 1, could be 20, could be 99, could be 75, could be 29. You get the picture. So the first thing we're going to do is we're going to say, sorry, I'm just reading my notes at the same time. Before I do that, I'm going to... All right, now this is where we're going to get a little tricky. I'm going to need to switch back to Unity for a minute, and we're going to make some changes to our code. Because what we need to do is, in that cell, we're going to basically write... Actually, I'll write the code here. So we're going to say, if board cells position... So we're going to get the position of the board cells from that, what's the name? And we're going to say has mine. So basically what we're saying is if it doesn't have the mine, so what we're going to say is we're going to say board cells position dot has mine equals true. And we're then going to increase mines placed so that this while loop won't get stuck in an infinite loop. Anyway, let's go back to Unity. And what we're going to do is we're going to switch the prefab over to our tile here that we would normally, what I'm normally going to use. And the other thing I'm going to do is I'm going to change this to tile because it's no longer going to be a game object. We are actually going to get a reference to the actual script, and we're going to store that in the script, in the list instead. So if we go back to the create game board, we can see that we've now got the error. So what we need to do is we need to go GetComponent tile, and I forgot to close it off. So that's now adding the actual script that's now attached to that component, to that object, into that list instead. So as you can see, the has mine has now satisfied that it's no longer an error because we now have that variable. So I'll go to the code and show you basically how it works. So this is what I usually do with this sort of where something's going to be changing. Like in this case here, I keep all the code that's going to be relevant to that tile on the tile script, and then I reference it like this. So as you can see, once we set the has mine flag, we then do a show tile. And the show tile then goes through and looks at all the parameters of whether it's been revealed, whether it's got a mine, or whether it's got a flag, etc., etc. And then it does what it needs to do to display. So if I was to run this now, so as you can see, we now have all those 10 mines. So if we go back to the code, we're basically saying here that rather than storing the game object and then doing a get component, then make the change to the script and caching that for every time we need to get an access to it. It just means that we cache the script and we do that. Now, let's say we now want to, say, calculate neighbors. Now, I'm going to... can't even spell neighbors. Not that it matters. Now, I'm going to copy some code for this one. Just bear with me for a moment, but I will run through the code. And I'm going to change grid to forward cells. Actually, I need to do that. And actually, no, I won't do. I'll leave it back to what it was, which is grid. And what I'm going to do instead is remove this, and I'm going to go private grid equals, because this is another class, private grid, what do I call it? It's grid, and I've got the lowercase, which is wrong, so apologize to anyone who picks that up. And what we're going to do is we're going to say grid equals new grid, so that we've got that reference then. And we're going to change this to grid dot grid cells, and we need to do the same thing for here and here. All right, so basically, yeah, I knew that was going to happen. I call this grid. Means I'm going to have to change these ones down here as well. It's easier to just change a few than many. Okay. All right, so technically I haven't changed a great deal, but the grid is just very simple. There's a lot of extra code in here as well that I won't go through for this, but I am doing this as a tutorial, so you can watch that later on if you like. So it's just basically holding that list reference in here so that we can add it to this. Now, when I did the calculate neighbors, I said I'd go through that. So here is that we're going through every tile that's in that in the grid, and we're going to say if it doesn't have a mine, right? So if we go back to, let me comment this out for now. Go back to the game. So basically what we're going to do is we're going to go through here and we're going to say, does this square at the very top left-hand corner, does that have a mine in it? If it doesn't have a mine, then we don't really want to do anything, because what we're basically doing with calculating the neighbors is for this here, for instance, right? So if we're on this here, we're going to say, okay, what cells around this have mines? And we can see that this has a mine, so it's going to put a 1 in here. And it's going to keep going, and then we'll get to something like this, where we've got a mine here and a mine here, so it'll put a 2 in here. All right, so in the code itself, when it goes into the calculate neighbors, now to do that, what we do is we usually get the... actually, I should have left that running, because there's another thing I wanted to show. So if I pause that, we can see here that the X and Y of each one corresponds to where it is in the row. So the very bottom row is going to be X 0 to 9, and the Y is going to be 0. all the way to oh yeah, is 0,9. So y being 0, 9 at the y being 9 is at the very top. Okay, so when we calculate the neighbours, we need to get the position of that grid. So as you can see here, rather than going off and getting the component transform, we know that the script already has access to the transform component. So why don't we just use that rather than rewriting code for the sake of getting something that we already have access to? So when we do that, we then get the X and Y of that, and then we set the neighbors, and then the get neighbors in here is then run down here. And all this is basically doing is going up and going to the top left, top right, left, right, bottom left, bottom right, down, right, down, and etc. So basically going in all 8 directions and checking to see if and getting that cell and adding it to the if that's within the and then it's basically setting that in the tile. So if we go to tile set neighbors, we can say down the very bottom here, we can see that it's doing that, and then it's calculating the neighbor count using a LinQ expression, and then setting how many of those have actually got a mine. And that's pretty much it. So if we go back to, actually, did I uncomment? No, I didn't. So if I uncomment this and then run it, we can see that the numbers should now be there. And as you can see, this one sticks out like a sore thumb because it's got 5. And if we look at the neighbors, we can now see 1 mine, 2 mines, 3 mines, 4 mines, and 5 mines. And of course, the ones that don't have any mines next to them are all blank. So that's pretty much it. Now, the other thing too is I do use LinQ expressions. And the reason that I use the LinQ is because it's actually quicker than... all right, let me explain. So if we go here, for instance, and we basically want to say neighbor count, and we say, all right, let's get all the tiles... right, because we've already got the neighbors, so we've calculated that and we've passed it in, and we're going to say, okay, does this tile have a mine? If it does have, and it's going to continually looping over all of them and basically saying, if it has a mine, get a copy, get a reference to it, and then count them up and return that count. So instead of writing a for loop and going through it, this is probably a quicker way of doing it. Now, there are other things that where I use it, nothing in there, but I do use it for checking to see if the game's won, etc., etc. But again, you can watch the final tutorial on creating the game to get around understanding how that works further down the track. Well, that's it for this video, and thanks for watching. If you enjoyed the video and would like to help support the channel, please do subscribe and hit the bell to get notified.